Good morning, dear student. In today's lecture, we are very much interested in the cyclic voltammetric study of ferroferricyanide redox couple. This cyclic voltammetry, it is also known as triangular wave voltammetry. It is also known as triangular wave voltammetry. Triangular wave voltammetry. So this cyclic voltammetry, it is also known as triangular wave voltammetry. It is the cyclic voltammetry. In this cyclic voltammetry, triangular voltage ramp is used. Second, that is triangular voltage ramp is used. Triangular voltage ramp is used means the potential is scan. That is the next point is that the potential is scan. Potential is scan at a fixed rate. At a fixed rate, potential is scan at a fixed rate from from initial potential initial potential to maximum from initial potential to maximum potential or positive potential or positive potential to the negative potential. So this cyclic voltammetry, it is also known as triangular wave voltammetry. In this, triangular voltage ramp is used and the potential is scanned at a fixed rate from initial potential to maximum potential or positive potential to the negative potential. This cyclic voltammetry, it is an electroanalytical technique and it is very useful for study of electroactive species, that is the species which undergo oxidation reduction reaction simultaneously. So it is very useful for study of electroactive species that it undergo oxidation or redox reaction. So if you see the graphical representation for this cyclic voltammetry, or how this why this cyclic voltammetry, it is also known as triangular wave voltammetry. So if you plot a graph, so this is the graph, that is if you plot the graph of potential versus time. So this is the graph of potential versus time. Potential having a unit of volt. So we can start from positive potential. So here the potential is positive, up to this it is 0, and here a negative potential is there. So positive potential, 0, negative potential. So we can scan the potential with respect to time from positive potential to the negative potential. So this here, this is the point, and then again we can scan the potential from more negative to the positive, that is initial potential. So this is the scan. Originally we back to home, or we can say that we can scan the potential from more negative to the original potential, that is positive potential, and this point it is called as switch potential or switching potential. So the potential at which we can change the ramp from more negative to the positive, then it is called switching potential. So the potential at which the scan rate is reverse, the potential at which the scan rate is reverse is called switching potential. Similarly the process is going on. So like this, we go from positive to negative, negative to positive, and this potential is called switching potential. And therefore this cyclic voltammetry, it is also known as triangular wave voltammetry. So At least you should know the positive potential, negative potential, then switching potential. What is switching potential? So in this cyclic voltammetry, a potential ramp is used, that is potential is scanned from positive potential to the negative potential, and whatever the current which is generated, it is measured, and the current is obtained in the form of peak, and therefore the current is called as peak current in this cyclic voltammetry. So this is your graphical representation for this cyclic voltammetry. The potential where the scan rate is reverse is called switching potential. So this is an important point. Potential at which scan rate is reverse is called switching potential, is called switching potential. That is, a scan in the direction of more negative potential is called as forward scan. A scan in the direction of more negative potential is called forward scan. That is, when you go from positive potential to the negative potential, means a scan in the direction of more negative potential. The second point is very important. The potential at which a scan rate is reverse is called switching potential. Again, a scan, that is potential can be changed. A scan in the direction, a scan in the direction, a scan in the direction of more negative potential, more negative potential is called forward scan, is called forward scan, is called forward scan, while the scan in the opposite direction is called reverse scan. So that is, the potential at which the scan rate is reverse is called switching potential. A scan in the direction of more negative potential, that is, we can transfer or we can scan the potential from more positive to negative. So a scan in the direction of more negative potential is called forward scan, while the reverse case is called as, that is, while the scan in opposite direction is called reverse scan. That is, a scan in the direction, a scan in the direction of more positive potential, more positive potential. Again we back from negative to positive. A scan in the direction of more positive potential is called a reverse scan, is called a reverse scan, a reverse scan. So at least you should know forward scan, reverse scan, and switching potential. So potential at which scan rate is reverse is called switching potential. A scan rate in the direction of more negative potential is called forward scan. A scan rate in the direction of more positive potential is called a reverse scan. It's called a reverse scan. As the potential is applied at which, so what happened after applying the potential at working electrodes? So we know that in this voltammetric uh, technique, three different types of electrode systems are used. One is working electrode, second is reference electrode, and third one is auxiliary electrode. And in this case, uh, we can control the potential of this working electrode with respect to the reference electrode, and whatever the potential which is applied at working electrode, and due to the application of this potential, as the potential, the next point is that as the potential, as the potential is applied, as the potential is applied, as the potential is applied at which, the potential is applied at working electrode at which electroactive species, electroactive species means the species which undergo oxidation or reduction. So the potential which is applied at which electroactive species start to react, start to react, start to react, means it under either go oxidation or reduction, and a current is flow, and a current is flow, and a current is flow through the cell, and the current is flow through the cell. As we increase the potential, which results to increase in the current, that is, increase in potential leads to increase in current. Increase in potential, increase in potential leads to increase in current, increase in current. Finally, we measure the current, whatever the current which is generated by the oxidation or reduction of electroactive species. So as the potential is increases, uh, which results to increase in the current, and the current is obtained in the form of peak. Whatever the current which is obtained in this cyclic voltammetry, it is obtained in the form of peak, and current is obtained in the form of peak. Current is obtained in the form of peak. The current is obtained in the form of peak, and the peak current at stationary electrode for a reversible electrochemical reaction which involve only electron transfer, single electron transfer, that is, so with increasing potential which results into the increasing current, which results into increase in the current, and the current is obtained in the form of peak for one electron transfer, for one electron transfer system, for one electron transfer system at electrode, for one electron transfer system at electrode, the peak current is given as the peak current, that is, it is denoted by symbol ip. Ip means the peak current is equal to 0.27 n raised to 3 by 2 into a into d raised to 1 half into v raised to 1 half into concentration. This peak current can be obtained from this formula. So it is only for a single electron transfer, or a single electron transfer in oxidation reduction of electroactive species. So the peak current, where n is nothing but the number of electron transfer, number of electron transfer, then A is nothing but the area of the electrode at which oxidation or reduction takes place, area of electrode, area of electrode having unit of centimeter square. Then D is your diffusion coefficient, D is your diffusion coefficient, D is your diffusion coefficient having unit of centimeter square per second. Then V is your scan rate, V is your scan rate, and then C is your concentration in millimoles. So from this equation, what it indicate, this equation or the peak current, it is the peak current equation, what it tells us, that is the peak current, it is directly proportional to the concentration. The peak current is directly proportional to the concentration, that is ip is directly proportional to the concentration. For reversible reaction means, that is, in this case we scan the potential from more positive to the negative potential, means the reaction is reversible, and from more negative to the positive potential means the reaction is reversible. For reversible reaction, the peak observed during the reverse scan is the same as peak observed during the forward scan. So we already know what is forward scan and reverse scan. So for reversible reaction, for a reversible reaction, the peak observed during reverse scan peak observed during a reverse scan is the same as peak observed during during forward scan, and two peaks are separated and two peak are separated by factor, that is delta E, which is equal to E of cathode minus E of anode, that is cathodic peak current minus anodic peak current. So this is the difference, which is equal to 0.058 upon N. So this is all about the theoretical or theory regarding to this cyclic voltammetry. So at least you should know this cyclic voltammetry. It is also known as triangular wave voltammetry. In this voltammetry, we can measure the potential, we can measure the current by applying the potential. But in this case, the potential, it is scanned from forward direction to the reverse direction, from more positive potential to the more negative potential, and the potential at which we can reverse the scan is called switching potential. And then the peak current, whatever the current which is obtained in the cyclic voltammetry, it is known as peak current. We discuss the equation of this peak current. Peak current indicate this equation indicates the peak current is directly proportional to the concentration. In the next lecture, we discuss the cyclic voltagram for this potassium ferrocyanide ferricyanide couple. So how this voltagram is obtained, we will discuss in the next lecture. Thank you.